Okay, yesterday you guys shifted up and down for me. Today, hey, we're going to stretch it and we're going to compress it now. That's what we're doing today. It is a whole different ball game today as far as what I'm going to have you guys do. Yesterday was nice. I just moved it up 3, down 2, whatever I had to do. But now I'm going to compress it and stretch it out. So everyone take a look. I've graphed 3 cosine x, something I could easily ask you guys to graph tomorrow on the quiz. All right, 3 cosine x. Starts at, instead of starting at 1, it'll start at 3. 0, -3, 0, +3. All right. Now, for the first time ever, I want to put a number in front of the cosine and the x. We have never put a number in front. We've always put a number out in front, but we've never put a number in between. All right. So how does that affect the graph? All right. Everyone go to your graphing calculators because we're going to do it on the calculator first. First thing you need to know, because this is your first experience graphing a sine and cosine on your calculator, you just can't go to y equals, plug it in, and graph. Okay, that's the first thing. Some things need to be done first, and that is, first thing, it's got to be in radian mode. Okay, if you ever want to graph a sine or a cosine function, you need to be in radian mode. That's the only time your calculator should ever be in radian mode, is checking a sine or cosine curve. Okay. You can go to the y equals screen right now. Don't hit graph, though. 3 cosine 2x, what we're about to graph. Okay? Everybody good? Okay, don't graph anything because it's not even going to look close to what you should be graphing. What we need to do now is adjust the window on our calculator. All right, so it fits the graph we're asked to graph on. So everybody go to window. And what I need you to do, yours is probably a lot different than mine because I've already done this third period. What I need you guys to do is look at the graph I'm asking you to graph on right now. Look at the x minimum to the x maximum. It goes from what to what here? On the x-axis, it starts at -2 pi and goes to 2 pi. So that's what I need to tell my calculator. Hey, x minimum, -2 pi. My x max should be also 2 pi. The scale. Look at your graph. We are going by pi over 2's. So you want your x scale to go by pi over 2. What about your minimum for your y and your y-axis, your minimum and your max? You guys know this already here. Ethan, what's the amplitude out in front of that graph I'm asking you to graph right now? 3, so you know it goes down to -3 and up to +3. So that's why I know my y minimum is going to be -3 to 3. It's the amplitude. And then you guys can fool around with this if you want. I'm just going to leave it at 1 for my y scale, go by 1s. Okay, we all good? And again, I have no idea why your calculator doesn't keep it -2 pi. It changes into the decimal it's equal to, but that's how the calculator rolls. Everyone good? So again, all I did was look at my graph, make sure it matched my window. That's all I did. All right. So now, if you have those measurements in there, go ahead and graph. You should see some cosine curves coming at you pretty fast, hot and fast. We see cosine curves there? Okay, what I need to do is take that graph and put it on the packet right now. Okay, take that graph, put it on the packet. So, here we go. Still starts at 3, right? Everyone's graph still starts at 3. So does mine. Starts at 3. So point right here. But now, if you take a look at your graph, at pi over 2, which is this first tick mark, pi over 2, what's your value? Goes down to -3, yep. So at pi over 2, now it goes down to -3 instead of hitting 0. And then it goes back up to 3, back down to -3, and where does it end at 2 pi? Back at 3. And again, I'm just looking at my own graphing calculator and plotting these points. And then go in the negative direction now. Same thing. -3 to 3, -3 to 3. if you want to get different colors, pen versus pencil, that's your call. Well, a little bit different. A little bit different. Can you also get the cosine sine curve that you guys did yesterday for me out, the basic sine and cosine curve out for me? Keep that off to the side, because you're going to need it to answer this question, the next question. Okay, look at one full cosine curve on that sheet you did for me yesterday. Everyone sees what a cosine curve looks like. One full cosine curve. Because now what I'm going to ask somebody is, when you go from 0 to 2 pi, from 0 to 2 pi, from 0 to 2 pi, how many of those curves do you see? Because it's not one anymore. All right, so when you go from 0 to 2 pi on your graph right now, how many cosine curves do I see? Ethan, pick somebody. Let's go. Lucas, how many cosine curves do I see? Everyone agree? You see 2. Ready? 1, 2. I see 2 full cycles. We're all in agreement. Okay? So I see 2 full cycles. I don't know if I could spell that right. So 2 cycles. Okay, no big deal. Let's do another graph. Everyone go back to your calculator. You don't need to change the window. Do 3 cosine 1/2 x now. Clear out the 2 cosine x1 or the 3 cosine 2x and do 3 cosine 1/2 x. I'll do the same. You guys, if you got a fraction template, use it. Let's see what this bad boy looks like. Oh, all right. Let's put that, I know the graph's going to start looking messy now, but let's put it on the graph. Still starts at where? 3. All right, great. Still starts at 3. But now take a look. You don't get a value. Where's it hit 0 at? Not at pi over 2, but at pi, yeah. So I'm not going to put anything at pi over 2. I'm going to put a 0 at pi. And it looks like it hits -3 where? Not 3 pi over 2, but 2 pi up. And I'll do the same in the negative direction. So it's going to hit 0 at -pi and hit 3 at -2 pi. Okay, here we go, Lucas. Who you got for me? Cooper, here we go. You got a cosine curve in front of you, right? You see what one full cosine curve looks like. I want to know from 0 to 2 pi again, how much of the cosine curve do I see? That's it. Everyone agree with them. I only see half. I don't see a full one. All right, I only see half of one. I see the first half of it. That's it. So yes, I see half a cycle. Do we see that? Half a cycle. Okay. Is there any relationship then? Reagan, go ahead. Well, this is going for this curve. And this is for this curve. If you let me teach, that'd be great, because you just totally stole my fire, because that's what I was about to say before you raised your hand. And I kindly answered your question before I finished my statement. But is there a pattern between the number, how much of the cycle you see in the equation? Yes, it is. All right, yes. You see 2, I had 2 cycles. You see 1/2, I see 1/2 of a cycle. What's that? I don't want to refer to it as that anymore and just point to it. All right, that has a name. All right, that number that's plugged in there in this part of the equation is now going to be referred to as our frequency, our B value, how much of the curve we see from 0 to 2 pi. All right? That's the value we're going to call the frequency now, all right? And it's going to be referred to as the B value, all right? The B value, how much of the curve we see from 0 to 2 pi. All right? So for this one right here, original curve I gave you, the first one you graphed, second one you graphed. I got a couple questions for you. Cooper needs somebody. Let's go. Somebody new. Let's go. Let's start hearing from different people. Pat, ready? Okay. Bonus question for tomorrow's quiz to help your fellow classmates out. What's the amplitude of this? 3. What's the minimum and maximum? Good man. He's ready to go tomorrow. Okay. That aside now. Frequency. 1, yeah. Because if you guys go back, or you guys can just look at the top of your paper, let me go back. This original black curve that we had here, you saw one cosine curve, right? That's the frequency. I saw one of them, all right? Now, let's get to this, which is also today's topic, period. Patrick, how long did it take that original curve I had on your graph to make one full cycle? 2 pi. Everyone agrees with them. It took 2 pi units like usual. All right. Not bad, Patrick. Nice job. So period, 2 pi. Now we get nuts. Go ahead. Need somebody, Patrick. Emma, ready? Frequency of the second graph. How many curves did we see from 0 to 2 pi? 2, and that matched my B value in the equation. See how the matching go right there, all right? I don't need a graph. I can just look at the equation, and it's whatever the B value is. Okay, Emma, here's big timer here. Big timer. How long did it take to make one full cosine curve? Pi. Everyone see that? It took from here, here to here. Here's one full curve in blue. Right here, one full cosine curve. It didn't take 2 pi anymore. It took from 0 to pi. Nice job. So the period was pi. We okay? Because it's going to get even crazier now. Emma needs somebody. What was your question? You ready? It's going to be on you. What's the frequency? What we saw half the curve. Ready? You can do this. I want you to think about it. Let me go back. From 0 to 2 pi, Brianne, you saw half the curve. So if I kept going, it would end where? If it from 0 to 2 pi, I saw half the curve. 4 pi, yes? 4 pi. If I kept going, it'd go another 2 pi and end up at, so it's going to take 4 pi now to make that full curve. All right, so the period there would be 4 pi. Are we okay? All right. There is a formula how to find period. There is a formula. I'm not going to give it to you right away, but I want you to see a relationship between frequency and period. Do you see the smaller the frequency gets? What do you notice about the period? Like as I went from 2 to 1 to 1/2, what do you notice about the period? It got larger. Everyone see that? That as the period got as the frequency got smaller, the period went from pi to 2 pi to 4 pi got bigger. So there's an inverse, what we call an inverse relationship. Big word there. Use it tonight at the dinner table. All right. As the frequency gets smaller, your period gets bigger. All right. The formula to find period is the following. Capital P, that's what we're going to refer to as the period, equals 2 pi divided by that frequency we just talked about, B value. That's how we're going to find the period, how long it takes now. All right, how long it takes to make one curve. We're going to take 2 pi and divide it by whatever the frequency is. Let's get into it. Brian, need somebody. Braden, ready? Going into tomorrow's quiz, what's the amplitude for part A? The equation I have in part A, what's the amplitude? 6, good. What's the min and max? Okay, we're ready to go for tomorrow. What is the frequency? 4. Here we go. Period now will be 2 pi divided by, what was the frequency, Braden? 4. I would like you to reduce it if you can. All right, 2 pi over 4 reduces down to 1/2 pi, pi over 2. Yep. Hey, hold on, before you get to part B. I want to know what you're finding. Just because you can do it and you can produce numbers for me, that's great. I want you to know what you're finding here. This is what this means. Everyone see the sine curve you have in front of them? See how that bad boy goes all the way out to 2 pi? What's this saying here? That this graph right here, you're going to see one of those from 0 to pi over 2. So, boom, done, pi over 2. All right, look, on your graph right now, imagine one full sine curve from 0 to 2 pi over 2. That's what that means. You're going to see another one to pi, another one to 3 pi over 2, and another one to 2 pi. You're going to see 4 of them total. That's a lot, right? They're just going to be going nuts. So that's what that means, right? One curve from 0 to pi over 2. Amazing. Unbelievable. I know you're jacked up. Braden, needs somebody else. Okay, here we go. Frequency. No X. I don't want any X's in my frequencies. Okay, whoa, what do we got here? Okay, you got to give him some, yeah, he's coming along for the ride too. Or she, sorry, ladies. All right. Pi over 3. Okay, period now. Now we're going to have to do a little algebraic work. 2 pi divided by pi over 3. 2 pi divided by frequency. We know how to handle this. We've been doing it all year long. Keep the top. What do you want me to do? Yep, you know, go. Oh, not both. I want to clean this up. So I keep the numerator the same. Remember this? And change this to. There you go. Got it. All right, complex fraction, keep the top, flip the bottom, multiply. What cancels out, Alex? The pi's, and I'm just left with period of 6. Yep. Now, hey, that's okay. We're going to see a lot of this now without the pi in there. That's fine. It's just 6 radians. All right, the period, it's going to take 6 radians to see a full cosine curve here. All right, that's fine. That's fine. Let's go, Alex. Need somebody. Matty Ice, here we go. B, what do we got for the frequency? 2/3. Wow, what's 2/3 of the sine graph look like? Well, I don't care, not my problem. All right. Period. 2 pi divided by 2/3. So that's going to be what? 2 pi times 3/2. What cancels here? The 2's are gone, so I'm just left with a period of 3 pi. So if I graphed out the 3 pi, I'd finally see a full sine curve. Oh, and a bonus question, Matt, because I know it's going to happen tomorrow on the quiz from a couple of your classmates, and it's going to drive me insane. What is the amplitude? Thank you. Positive 12, everybody. It cannot be negative. All good? Questions on finding period or frequency now? Okay, tomorrow on the quiz, I will ask for period. All right, and I will ask for frequency. Okay, I am going to ask that tomorrow on the quiz. Also, maybe on the quiz tomorrow, just throwing this out there. What if I give you the frequency? If I give you the period, can you find the frequency? If I tell you the period is 4 pi, can you find the frequency? By plugging in 4 pi and cross multiplying, we're going to be okay with that? Yes, no, maybe. I think it's on your assignment too. Just trying to tell you to maybe try it out tonight. We good? Okay, let's graph. Here's the problem we're going to run into now, and this will not be on the quiz, but it still doesn't matter. It's still the big chunk of the unit right now. Here's the problem we're going to run into. You guys have always anything I've asked you to graph has had a period of 2 pi. So that's why you could set up pi over 2, pi, 3 pi over 2, 2 pi. no big deal. But now what if the period's not 2 pi? What if it's something else? And I can't use those values anymore. All right, let's do it. Here we go. Matt, need somebody. This is big timers now. Only big timers only. Brooke, ready? Still got to find the period and the frequency. So what's the frequency? 1? Yep. You sure about that? Amplitude's 1. Half. Remember, the frequency is in between the cosine and the x. So a half. How can I find the period, Brooke? There we go. So that's going to be 2 pi times 2. So the period's going to be 4 pi. Okay. Got it. So this graph's going to take all the way out to 4 pi before I see a full cosine curve. Got it. Got it. So because the period's, because the period's not 2 pi anymore, you're not going to have values at all these spots. You're not. That's only for 2 pi. You're going to have values at all these spots. Well, where are you going to have values? This is how you find out. Here's where the key values are. Here's how you will find out where you're going to put a point. Do you see every graph I gave you is divided equally into how many different sections? Ready? Count them up. 1. Let's try that again. I don't think I was detailed enough. 4 equal sections. Everyone agrees? So how can you divide up 4 pi into 4 equal sections? All right, well, 4 pi divided by 4 or times a fourth, either way. So now this tells me I'm going to have a y value at every what? Not every pi over 2, but every, what crosses out here? 4s are gone, so I'm going to have a key value at every pi. And let me show you how this works. You ready to go back to work, Brooke? Have confidence. You got it. Okay, what curve are we doing, by the way? Sine or cosine? Cosine. So take a look at your cosine. Everyone else, take a look at your original cosine curve. What's the amplitude here, Brooke? 1. So it's still going to start at 1. Yeah, heck yeah. It's still going to start at 1, everybody. This cosine curve is still going to start at 1. Here's the difference, though. There's not going to be a value at pi over 2 because we said there's a key value at every pi. So you ready, Brooke? Cosine starts at 0, then goes down to what? I'm sorry, starts at 1, then goes down to what? Look at your curve. Goes down to? Goes down to 0. Everyone agrees. Starts at 1, goes down. But now, hey, not here it's not. Because we said there's a value every pi now. So that second value is going to be at pi. Keep going, Brooke. 1, 0, -1. But where should I plot that? At 2 pi. Perfect. That's all I'm plotting there. Because there's only key. That's what I mean by a key value. 1, 0, -1. Those values appear every pi. All right. And then graph. Boom. You guys are all right with that, how that worked, why there's not a value at pi over 2, because the period was different. Okay? Questions? What if we do it from scratch then? Like we make our own x and y axes, getting a little crazy. Brooke, need somebody now. Again, big timers only. Okay, ready here? Period frequency. That's all I need that first. Pi over 4 for the frequency. Okay, a little work for the period. It's going to be 2 pi divided by pi over 4. So that's going to be 2 pi, calm down, times. What cancels? Pi, so what's the period here? 8, got it. So it's going to take 8 radians to do this. All right. Need somebody else, Reagan. Thank you. Emma, ready? Key value. Key values. I'm still going to break this up into 4s. So 8 I know it's going to take me a total of 8, but I got to divide that up into 4. So you can divide by 4 and multiply by a fourth. I'm going to have a key value every what, Emma? 2 radians. Yep, every 2 radians, I should have a key value. Okay, let's make it up. We know how these start, right? Got my y-axis right there. And x-axis, somewhere that looks like it's in the middle. You don't have to count. What's the amplitude, Emma? 1. So somewhere you got to have 1 and -1. I try not to scrunch these graphs in. I try to spread it out over the graphs. 1, 2, 3, 4. So whatever you want to go by that represents 1. I go by 4s here, but that's up to you. Need somebody else, Emma? Brienne, ready? I need a key value every 2, right? All right, so again, you guys can go however many units you want. It's up to you. Okay, you can go by 2s, by 3s, 4s. I don't care. I'll go by 4s just to spread it out. 1, 2, 3, 4. So my first value here is going to be every key value every 2. Not 2 pi, 2. 2 radians that represents. And guess which? 1, 2, 3, 4. Guess what the next one's going to be? 4. Every 2. Every 2, I'm hitting a key value here. Perfect. And let's finish this off here. 4. 1, 2, 3, 4. Next one, Brienne. 6. Sorry. And then 1, 2, 3, 4. 8. Hey! That's where the graph's going to end. That was the period. I've created 4 equal sections. Perfect. Graph's going to end at 8. Somebody asked, third period, does it really have to end at the very, very end? No. It can end. It's going to end right here. It doesn't have to end at the very end of the graph. Okay, that's a you call. Okay, I don't know who we're going to pick now. Isabella, ready? Do you have your sine curve on you right now? And everybody else have their sine curve on them too. Isabella, what's the amplitude here? Yes. It's 1. So it's only going to go up to 1 and down to -1. Where's sine always start? Okay, so guess what? That's where this sine graph's going to start, at 0. Where does it go? What's the next key value on the sine curve? Goes up to? It does. On the sine curve, starts at 0, then it goes up to what? No. Your original sine curve you did yesterday. After 0, what's the next key value? 1. So instead of at pi over 2 at 1, it's going to be at 1 at 2 here. Boom. What's the third key value? I got 0, 1. Where's it go now? Back to 0. Next key value, -1. The power of knowing those key values on the original curve. And then it ends at, there you go, everybody. Took 8 radians to make 1 full curve. You like that, Matt, don't you? It's a decent curve. All right. Anything you want to ask? I'm going to do one from the assignment with you. All right, so we don't panic tonight when we try this out. Is everyone good right now? Okay, because I am never going to give you your own graph again. All right, you're going to set up your own now. Okay, you will be responsible for setting up your own. Go to number 5, please. Number 5 on the assignment. Who you got for me, Isabella? Anna, ready? All I need, period and frequency. That's all I need from you. Frequency according to this equation. What is it? 2. Period. How do I find it? 2 pi divided by what, Anna? 2. What cancels out? So I'm left with pi. Got it. So my graph should end at pi. That's what that's telling me. Your graph's going to end at pi. What are the values before it, though? All right, you're going to break it up into equal sections of 4, right? So pi times a fourth. I'm going to have key values every, Megan? Every pi over 4. Yep. All right, let's do this. Ugh. Come on, you're better than that. Megan, what's the amplitude? It's still 1, right? So still going to go up to 1 and down to -1. Okay, this is why I particularly picked this one to do with you guys. Key value every pi over 4, right? So there's my first value on there is pi over 4. Whatever you guys are going by. Hey, just a quick, I don't know if anybody read the directions yet. I wouldn't space this out real far. You see the directions, what I need to do here? Find period frequency, I did that already, but I need to complete 2 cycles here. All right, so I'm going to go past pi in a second here, but I got to do 2 cycles, so I wouldn't go out too far spacing them. But the first one, whatever your spacing is pi over, bless you, 4. Now that last one for Brienne, when she did it, was pretty easy because all she had to do was count by 2s. But now we're going by what? Pi over 4s. Ooh. Ready? I'll make it simple on yourself. 1 pi over 4. So the next one's going to be? Keep counting. 1 pi over 4. 2 pi over 4. You can reduce that if you want. I don't care. Next one? 3 pi over 4. Next one? 4 pi over 4, also known as pi. There's 1 full cycle for you guys, right? Because that was the period, pi. There's 1 full cycle. Keep going, though, because we need 2 cycles. What do you think the next one's going to be? Keep the pattern going. You got 1, 2, 3. There's 4. 5 pi over 4. Next one. That's what I'm going with. 6 pi over 4. You can reduce that if you want. That's fine. Lucas, finish it. 7 pi over 4. And then finally, 8 pi over 4. Easy. Some of your classmates may not be ahead of that. All right. 8 pi over 4. Also known as 2 pi. Okay. Cosine curve. Everyone look at your cosine curve. If you don't know the key values already. Where's cosine start? And on this one will also start at 1 because it's the amplitude is 1. I don't want it. Yellow. Yeah, we'll go yellow. After 0, next, or after 1, next key value. I always give it away. Is 0. Yep. So at pi over 4, it's 0. Next key value. I got 1, 0. Negative down to -1. Next key value. 0. Finishes back at 1. And then we start repeating once again for the second cycle. Okay. And what was the frequency for this one again? What was the frequency? 2. And guess how many curves I see from 0 to 2 pi? 2. All right. You guys, you have to try some of this out. because after the quiz tomorrow, I'm going to start putting an amplitude in front and shifting it. That's where we're going with this. All right, is from here doing these basic ones with a new period in there, and then I'm going to put a new amplitude and a shift in there too. So you got to try these out, making sure you can do it. Start it up. Go ahead. If you want to do number 6 while you're there, try it out. Go right ahead.